Welcome, data engineers and architects. Today, we are exploring a highly efficient, task-specific AI function in Snowflake Cortex, Extract Answer. Let's get started. Let's begin by defining the Extract Answer function. In enterprise data, we frequently encounter massive blocks of text like contracts, emails, or logs. Finding specific information hidden within them using traditional SQL or regular expressions is incredibly frustrating because human language is unpredictable. Extract Answer is a task-specific Snowflake Cortex AI function designed to solve exactly this. It accepts a source document and a natural language question, returning the precise answer found within that text. Why is this revolutionary? Because you are leveraging the semantic understanding of large language models directly within your database. You no longer need to move your data to an external AI service. By simply applying this function to your unstructured or semi-structured columns, you immediately convert chaotic text into clean, queryable answers. Look at this flowchart to see the simplicity of the architecture. On the left, we provide two inputs, the source document containing our raw data and the natural language question we want answered. Both flow directly into the Extract Answer compute engine in the center. The function applies its specialized LLM logic and outputs a concise extracted string answer on the right. It acts as an intelligent filter, removing the noise and handing you exactly what you asked for. Let's look at how you actually write this in your SQL code. The syntax is incredibly straightforward. You call extract answer, pass in your source document column, and then your question string. The function will return a clean varchar string containing just the answer. What makes this particularly powerful is the data formats it supports. It effortlessly handles standard plaintext documents, like customer reviews or long email threads. But a deep dive feature is its native support for string representations of semi-structured JSON objects. This means if you have deeply nested API logs or complex JSON payloads, you don't necessarily have to write complex lateral flattened queries to find a specific data point. You can simply cast the JSON to a string and ask the AI a question about it, saving immense development time. This diagram illustrates the input flexibility of the function. Your data types can branch into either plain English text, like an article, or a stringified JSON object, like a machine log. Both data types are valid inputs for the Extract Answer engine. The engine normalizes the context and outputs a clean string output regardless of the original structural complexity of the source data. As senior data engineers, we must always consider system limits and costs. Because Extract Answer uses a specialized, Snowflake-managed model, it operates with specific token boundaries, a maximum of 2,048 tokens for the source text and 64 tokens for the question. This makes it ideal for processing paragraphs, abstracts, and moderate-sized JSON payloads. From a financial perspective, it is remarkably efficient. It costs only 0.08 compute credits per 1 million tokens processed. This is a massive advantage. If you used a massive general-purpose model to do this simple extraction, you would pay significantly more and incur higher latency. Remember, to execute this, your role must be granted the Snowflake.Cortex user database role. As a best practice, if you have massive documents, use a chunking function first to break the text into smaller segments before applying Extract Answer. Let's visualize these crucial boundaries. On the top left, we have the source text block capped strictly at 2,048 tokens. We combine that with the question block, which is capped at 64 tokens. These tightly controlled inputs flow down into our cost block, resulting in the highly efficient pricing of 0.08 credits per million tokens. This strict parameter management is exactly why this function operates so swiftly. While SQL is powerful, many data pipelines are orchestrated in Python. Extract Answer integrates seamlessly with Snowpark Python. To use it, you must ensure the Snowflake ML Python package is installed. You simply use the import statement from Snowflake.Cortex import extract answer. From there, you can apply it directly to a data frame. For instance, if you have a pandas data frame with a column of text, you can use the .apply method, passing the extract answer function and your target question. This deep integration means data scientists can ingest raw text, use Python for initial cleaning, apply Cortex AI to extract the exact answers they need, and then immediately train downstream machine learning models all without the data ever leaving the Snowflake compute environment. This sequence diagram maps the Python execution flow. The Python script loads data into a Snowpark data frame. The developer calls the apply method with the extract answer function and the target question. The data frame pushes this workload securely down to the Cortex engine. Cortex processes the text batch, extracts the answers, and returns them to the data frame. The Python script now has a fully structured dataset ready for advanced analytics. As technology moves fast, so does Snowflake. It is important to know that AI extract is the newly updated version of the extract answer function. While extract answer is fantastic, AI extract removes many of the older limitations. It supports multiple languages, processes significantly larger context windows, and even supports multimodal extraction from images and documents directly. Snowflake maintains backward compatibility, so if you have production pipelines running the legacy extract answer, they will continue to work perfectly. However, the deep dive architectural advice here is simple. If you are building a brand new data pipeline tomorrow, you should transition to using AI extract to ensure you are benefiting from the latest underlying foundation models and expanded feature sets. This simple evolutionary graph shows the progression. We start with the foundational extract answer on the left. It evolves into AI extract. Branching out from AI extract, we see the massive upgrades, multilingual support, larger context windows, and multimodal extraction for images and documents. It's the same core concept, supercharged for enterprise scale. When running AI functions across millions of rows of unpredictable text, you will inevitably encounter edge cases, perhaps a corrupted string or a payload that radically exceeds token limits. By default, a function failure will abort your entire SQL query. To build resilient pipelines, you must understand Snowflake's try pattern. For example, try complete performs the exact same operation as the standard LLM function, but if it encounters an unprocessable error, it gracefully returns a null value instead of crashing your pipeline. Why is this critical? Because in a massive batch ingestion, you cannot let one bad record halt your data warehouse. As a deep dive strategy, use these try functions, and then write a subsequent query to filter for the null results. Route those failed records into a dead letter queue table so a human analyst can review them later. This pipeline diagram shows how to build for resilience. We feed 1 million rows of text into a try AI function block. The workload splits. Successful extractions take the left path, returning the answer and flowing into the clean production table. When a row fails, it takes the right path, returning a null instead of an error, which we systematically route to a dead letter queue for manual review. Your pipeline never breaks. Let's apply this to a highly valuable real-time use case, customer support triage. Imagine your company receives thousands of free text emails every day. Customers complain about issues, but the data is buried in paragraphs of unstructured text. Your goal is to route the ticket based on the device model and date of incident. Instead of building a fragile regex parser or hiring manual data entry staff, you use Snowflake Cortex. As the emails land in a staging table, you execute a query, select extract answer, email body, what is the device model? The function reads the chaotic email, finds the device name, and returns it as a clean string. You instantly populate a structured device model column. You have just transformed unstructured chaos into structured, dashboard-ready data in seconds, completely automating your triage workflow. Let's trace the automation. The email ingestion system inserts the raw, unstructured email text into our Snowflake table. The database immediately triggers extract answer, asking, what is the device model? Cortex parses the email and returns a clean string, iPhone 15 Pro. With that structured data point now available, the database triggers the routing logic, automatically sending the ticket to the mobile support team. Zero human intervention required. To summarize, extract answer is your go-to task-specific function for pulling precise data points out of unstructured text and JSON logs. Because it runs natively inside Snowflake, your sensitive data never leaves your secure perimeter, and you pay zero egress fees. Remember to architect around the 2048 token limit by chunking larger documents, and start transitioning your newer workloads to the upgraded AI extract function for multimodal and multilingual support. By mastering these Cortex AI functions, you drastically reduce the time it takes to turn raw text into actionable business intelligence. Thank you for joining this session. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final mind map summarizes our entire lesson. At the core, extract answer takes a question and text to return a string. It flexibly handles plain text and JSON strings. It is bound by highly efficient limits, 2048 tokens for text, costing a fraction of a credit. And finally, we look to the future evolution with the AI extract function. Keep this mental model handy as you build your next generation of AI data pipelines.